of determining soil particle size. Are we listening? Yes. The first method is what is called sedimentation method. That is from the word sediment. Sedimentation method. And in that case, that is the aim. The aim of the experiment is to determine sedimentation experiment. That is the particle size of the soil. So in sedimentation method, we need an equipment called a measuring cylinder. Measuring cylinder. Then the procedure goes thus. This is a measuring cylinder. Yes. You take a sample of soil. A sample of soil. Have you seen it? Then you pour it inside the cylinder. You mix it thoroughly. Mix it thoroughly and pour it inside the cylinder. As thus. To a no measure. So we are pouring it. Then after that, the next thing you are going to do is to add some quantities of water. You add some quantities of water to it with a solution of hydrogen peroxide. Look at it. A solution of hydrogen peroxide. The aim of adding hydrogen peroxide is to break any organic matter that might cluster the particle together, might tighten the particles together. Is that clear? So the organic matter will be broken with the addition of hydrogen peroxide. Is that clear? Which has been added. You are going with this one. Then you stir it thoroughly. You stir it thoroughly. Stir it thoroughly. Then after a while, you leave it to settle down for a few minutes. After stirring it thoroughly, you leave it to settle down for a few minutes. Is that clear? So these are the procedure you are going to follow. After you have left it for a while to settle down, then the next thing is to go back and look at the way the particles are settled down according to the size of the particles. Are we together? The way they are settled down. If you look at this cylinder, the total height of the particles is somewhere around 160 mil. These cylinders ranges from 0 to 500 mil. Is that clear? Yes. So we now look at where the particle settled. Look at the particle from the bottom up to this place. That's where the particle settled. Isn't it? Yes. So almost 160. That's 160 mil. Is that clear? Yes. So the aim of that, the reason for that is for you to know how to calculate the proportion of sand, silt, and clay in that soil particles. Is that clear? Yes. So having know the total height of the soil particles, having know the total height of the soil particles, total height of the soil particle. So the height of the sand first will be known. Height of the sand abbreviated as HSA, which is equal to, if you read it, you can read it. This is what you can do by yourself. From the bottom, the sand particles, you see from the bottom up to this around 60 is they are bigger particles. So that is 60 divided by total height of the particle. What is total height? 160 multiplied by 100 over 1. Is that clear? For you to determine the height, the proportion of sand in that particles, in that soil particles. So the height of the sand divided by the total height multiplied by 100. Is that clear? Which is equal to what? What is equal to what? 37.5. Huh? 37.5%. Then height of a silt 8 years high indicate height of seat equal to, if you go by from that 60, you read from that 60 up to around 110, go 120. So that is from 60 up to 110 or 120. 60 up to 120. What is the margin there? What is the margin? 60 to 120. 60. Go? Yes. Good. 60. So the height of seat is also 60 divided by what? 160. Is that? Yes. 60 to 120. Yes. 60. Go. Multiply by 100. Our answer is equal to what? 37.5%. Then height of a clay, 8 ca. Height of clay equals what? The remaining one. You know the total height is 160.
So 60 divided by 60. That's 100. Oh, 160.
160. The height of a clay. What is the balance? 60 plus 60. 120. Then what remains? 40. See, the total height is 160, isn't it? Yeah. The total height is 160. So what you have as balance is 40, isn't it? 40 over total height, 160 multiplied by 100. What is the answer?
25.
25%. 25%. So if you want to confirm whether you have the equal numbers of the total amount of soil particles in that soil sample, you add the three together and will be equal to 160. It must be equal to total height of the soil sample.
It's 100.
100. Okay, this one is a percentage. Sorry, it must be equal to 100. Is that clear?
Yeah.
That's another method. The second method. Any question on that?
No.
The second method is what we call by sieving. Sieving. That is the use of sieve. Are you listening?
Yes.
It's by sieving. Look at it. Here, come. You come. Come. In sieving method, you are going to use sieve of different diameters. Look at it. Different diameters. This one is smaller, or the smallest cell, followed by this one. While this one has the largest diameter. Is that clear? So these are the sieves that are going to be used in sieving method. That method is called sieving method. Is that clear? Just like the way you sieve your flour at home. Do you understand? So it means that you are going to take a no weight of soil sample. No weight. You are going to weigh it. Yeah? You are going to weigh, and this one has been weighed in the chemistry lab. To be 50 grams. Is that clear? Yes. So after taking the weight of the soil sample, we'll pour it on the sieve of the largest diameter first. It's the one that is going to be on top. Put this. Put this inside now. Put like this. Keep on sieve. You can see. This is what's called sieving method. It's also used to determine the particle size of a soil sample. Okay? You can see. So we discovered that the particles of larger size were held by this sieve. Look at it. Yes. Yeah, they cannot pass through beyond this level. So they are in the first sieve because they are very large size. Look at it. Yes. So, and you look at the second sieve, there are also some particles there that cannot pass through the sieve. You can see. Yes. Then you go to the third one. There are also some particles there that cannot pass through. You can see them. So what we do to know the percentage or the weight of the soil sample that pass through. So it's for you to do what? You put this one inside a container and measure it. Look at it. Yes. Do the same thing for the second one, then the third one, and the filtrate. The filtrate are the one at the bottom, inside the container. Is that clear? So that will give you the exact amount of particles present in that soil samples. And you look at this one now, meaning that this particular soil sample has a largest particle size because it holds a lot of particles. Look at it. So that is another method of determining the soil particle size. Is that clear? Good. Now, let's go through the third one. The third one, there is a sieve. Where is it? The sieve is missing.
Yes.
Huh? Check that box for me. You over the back. Okay, stand up. Check either down, open it. Either the seat there. So in this time, that is experimental. This one is to determine the porosity or drainage of various soil sample. The porosity or drainage of various soil sample. So in that case, normally by porosity, drainage, drainage, porosity, permeability, retentivity. Look at it. How different soil types can retain water. That's what is meant by porosity. You have 3 types of soils. The commonest 3 types of soil. Mention them. Sand, silt, and clay soil. So the 3 soil samples will be provided. And you come. Adam. Get those sand outside. Yes. Yeah. In this case, what apparatus do you need for this purpose are the same your measuring cylinder. Is that clear? Yes. So, in that case, you are going to put a cotton wool inside the funnel. You need a funnel. Look at it. Yes. You put the cotton wool inside the funnel. This way. Put the cotton wool inside the funnel. We need a stopwatch. Stopwatch. So we need stopwatch for that purpose. So what we'll do, we take a nose sample of soil. A nose sample of soil. Equal samples of soil. This will be taken equal sample as thus. Then we take that of a clay. Take that of a clay. The boy has come with sand. Take that of clay. This sand is smooth. Smooth. For sand. Yes. Having put the different soil samples inside the cylinder. Look at it. you want to know which one will drain water faster than the other. Is that clear? That's what's called soil porosity. If the soil is porous, you will know. If you pour water inside it, it drains faster. You can easily determine the type of soil it is. Isn't it?
Yes.
And if it's very, very slow in draining water, then it will be what? So don't let us go to conclusion yet. So, but you have set up the experiment. The next thing is to add water. That's the reason why we need a stopwatch. Look at it. So that we determine the size, the time we are adding the water. Okay, good. Yeah. So this one may take some time. It may take us some time. Okay. Is that clear? You can see immediately we added water, a particular soil sample. The water began to drain out immediately. You can see. Why? In the other two, you have never observed the drainage of the water. The water is going to drain, but it may take time. So where we are going is this. You can see this one that drain water very faster. What type of soil can it be? Sandy soil. Look at it.
Yes.
It drains water very faster. So the soil will be sandy.
Yes.
Look at it.
Yes.
So the one that follows will be what? Loamy soil. And the least one will be what? Clay soil. Will be the last soil sample that will drain water. Is that clear?
Yes.
Do you understand?
Yes.
So this is another method of determining the porosity or the sensitivity or drainage of soil. Do you understand? Do you understand? So that is any question? Ask me a question. Yeah? As O-level agric science concerned, you have practical exams, you have objective tests, questions, and you have essay questions. So these are part of your practical exam questions. Is that clear? So you should be expecting something of this at the end of the term. Question. Pause your listening for now. Cameraman, let's pause it for now.